So it just stays square root of 3. But 9 divided by 3 is 3. So my new coefficient is 3. And that is the length of my short leg. Questions on how I determine the length of the short leg? Okay. And then to find the hypotenuse, you just got to double it. So this is going to be 6 square roots of 3. Because I have 3 over here, 3 of these square roots of 3. When I double it, I'm still going to have a certain amount of square roots of 3. It's just I have twice as many. So 6 square roots of 3. Questions on 30, 60, 90s? Okay. And the last one. For number 6, solving for the side legs. Can I use Pythagorean Theorem? Yeah, because I have 2 side legs, so we can definitely use Pythagorean Theorem. So I got 19 squared is equal to 16 squared plus, I'm just going to call that A, 1 up. So 19 squared is equal to 16 squared plus A squared. When you solve this, I'm going to get that A squared is 105. So what do I do now? Take the square root. So the value of A is the square root of 105, and then we can reduce that and simplify that. Actually, we can't simplify that. So this is exactly A, or the length of the third side is exactly square root of 105. However, we need to determine these angle measurements. We need to determine these angle measurements. So I'm going to call this one N for Niven, A for awesome, and T for terrific. Okay, so this is just random vertices, so we can figure out some angle measurements. I don't know this angle measurement, whatever you decided to call it. I decided to call it angle N. I don't know this angle either. These are the 2 acute angles in this right triangle. So how do I go about solving for angle measurements in right triangles? Say it louder. Inverse trig functions. Okay, so you use what is printed on your piece of paper. I'm going to solve for angle A first, alphabetical. So I know that I'm searching for the measure of angle A. Well, the measure of the angle always goes inside the set of parentheses, but I need to figure out what trig function I'm going to use. Use what is printed on the piece of paper. So for angle A, this top angle up here, with respect to it, I have my hypotenuse, and I have my opposite leg. This is on the complete opposite side of the triangle, and that's my hypotenuse. So you ask yourself, what trig function involves the hypotenuse and the opposite leg? It's sine. The ratio for sine is the opposite leg divided by the hypotenuse's leg. We are not solving for a side length right now, so we're not going to put this over 1 and cross multiply. We need to get this by itself. And currently what's happening to the measure of angle A is we're taking the sine of it. So we need to do the inverse on both sides of the equation. And that would be the inverse sine function. So that we are left with inverse sine of 16 divided by 19. And that is your exact answer. We are taking the inverse sine of both equations, or sorry, both sides of the equation. So in red is all the maths that's happening behind it, behind the scenes. So this is you plugging your values in. If you're solving for an angle measurement, you do the inverse trig functions. On the left-hand side, those cancel out, leaving you with just the angle measurement that you're trying to solve for. And then on the right-hand side, you have the inverse of the trig function of whatever ratio of the side lengths that you have. So you plug this in. To access these inverse trig functions, you must first hit the blue second button, and then whatever sine, cosine, or tangent, whatever trig function you're using. And then the calculator will put that -1 up there, the inverse. And so what you're asking the calculator is, hey, what angle has the sine ratio of 16 divided by 19? And so the calculator has those values in it. So can we get a rounded? I just erased the exact, but what is the rounded to the nearest tenth? 57.4 degrees. Does everyone agree? Wonderful. If you don't know how your classmates are getting this value, you need to ask questions. Now solving for the measure of angle n. I have to erase all of this that was on there because now that I changed my perspective to a different angle in the right triangle, those legs are different now. Now, this side that's labeled 16 that was given to us, this is now your adjacent leg. This stays as your hypotenuse, but this will change what trig function we're going to use. For the measure of angle n, what trig functions involves the hypotenuse and the adjacent leg? That's cosine involves those two. So we look at our form in the chart, and the ratio for cosine is adjacent leg divided by your hypotenuse's length. So cosine and measure of angle n right now is going to equal 16 divided by 19. You do the inverse trig function on both sides. So for this example, this is the inverse cosine. So my exact answer is the measure of angle n is exactly inverse cosine of 16 divided by 19. When we plug that into our calculator, we're going to get a decimal answer. And so it'd be 32.6.
Yeah.
Okay.
You also just add 57.4 and 90.
Make sure that you follow the instructions. If it asks you to use trigonometry to solve with both angles, I would need to see this. So I need to see like the exact answer you use trigonometry. Okay, so here's my notation for the rounded answers. I've got the measure of angle n is about 32.6. And I circle my rounded answer. Questions and concerns? Okay. Okay, let's go ahead and clear off our desk. Calculator, well, keep the calculator, keep the pencil, keep form and chart.